Alright, today's lesson 5.7, part 2, 5.7b. We're finding the zeros of polynomial functions. You're going to need the calculators today. Alright, basically, when you're working through here, I'm not going to do that. First part, don't really need it. With the calculators, you don't need this, and we don't need that. Alright, we will be able to find everything that we need with the calculators, and then we'll be decaying polynomials until we get into the second degree. Alright, let's just take a look at this one here. We're going to be using our calculator. Alright, and the equation is x to the third minus x squared plus 2x plus 4. So let's pull up our calculator screen. Alright, remember menu. Then we'll want to choose Algebra, Polynomial Tools, Complex Roots of the Polynomial. We had x to the third power minus x squared and plus 2x and plus 4. Tell the calculator what the variable is, comma x, and push enter. Okay, now as you can see right here, let me copy this over to the other screen so that we can look at this together. Alright, in this problem right here, you can see that what we've got are basically 3 roots represented, which we would have to have because it's third degree. Now, as I look at this, I notice that one root is easy to work with, and that's the -1. These others are imaginary numbers involving square roots because of all the decimals. So, let's use that -1 right there. We're going to decay this polynomial down. So I've got x to the third minus x squared plus 2x plus 4, and that was a -1 that we had over there. Let's decay this polynomial down from a third degree to a second degree. Drop, multiply, place, add. Multiply, place, add, multiply, place. And of course this has to be 0 since we already know that one of the roots was -1. So we've already got that -1 root, and now here we have this new polynomial. Alright, basically I've got x squared minus 2x plus 4. Alright, 2 methods to do this. Method number 1 is to complete the square. Set it up like this. Not like that. Try again. There we go. X squared minus 2x plus 4 equals 0. This is completing the square. X squared minus 2x, let's create a blank here and move your positive 4 to the back, make it -4 and create your blank here. Half of 2 is 1 and 1 squared is 1. Place it here and here. Factor this apart. X minus 1 quantity squared equals -3. Square root of both sides, that would give us x minus 1 equals plus and minus the square root of -3, which now then, we know that the square root of -3 is 3i, so I'll take care of that in a second. That gives us x equals 1 plus minus I root 3. So there are your 2 other answers using completing the square. 1 plus I root 3 and 1 minus I root 3. Okay, now let's suppose you don't like completing the square. Suppose you'd rather use the quadratic formula. That is not a problem at all. Alright, just remember that we're going to be using this polynomial right there. A is 1, B is -2, and C is 4. So, -b, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. And let's just start substituting in. Alright, b is a -2, so -b would be a +2, plus and minus the square root of b squared, so -2 squared is 4, minus 4 times 1 times 4. So that's going to be minus 16, all over 2 times 1, which is 2. Alright, 4 minus 16 is -12. And the square root of -12 is going to be, well, 12 is 4 times 3. Square root of 4 is 2. So that would give us 2 I root 3. And once again, that would be square root of negative 12, which would be the square root of negative 1 times 2 times 2 times 3. Bring out the negative 1, that's where the I comes from. Bring out a pair of 2's, that's where the 2 comes from, 2I root 3. Okay, so now then, divide that by 2. And when you simplify this, 2 over 2 is 1, and 2I root 3 over 2 is I root 3. It will give us the same answer as this. Now, the only other thing you're going to be doing today is writing equations. One thing to remember is the complex conjugate theorem tells us that whenever we have one imaginary number, we have another imaginary number also. They always come in pairs. So, for example, if 3 plus 4i is a 0, then 3 minus 4i is also a 0 in the function. Also, if something like negative 2 were 1, 0, then I know that positive 2i would have to be a 0 as well. Let's take a look at these two problems. Okay, this one right here doesn't have any imaginary numbers, so when we're going to write a polynomial function, then I'm just going to say, okay, one of them has to be x plus 3. Remember the opposites rule. X plus 5. X minus 1. Let's go ahead and FOIL out the first two. That would give me x squared plus 5x plus 3x, so that's plus 8x, plus 15. That's the multiplication of the first two. Alright, now let's go ahead and multiply this one times that one. X squared times x is x to the third. X squared times negative 1 is minus x squared. 8x times x is 8x squared. 8x times negative 1 is minus 8x. 15 times x is 15x. And 15 times negative 1 is minus 15. Combining your like terms now, this is going to be x to the third power. Negative x squared plus 8x squared is plus 7x squared. Negative 8x plus 15x is plus 7x minus 15. And that problem is complete. There is your polynomial of least degree with integral coefficients that has these given zeros. Now let's take a look at this one. It's imaginary. So I know that one of my roots is, one of my binomials is x minus 3i. But also remember, they come in pairs. So if positive 3i is a root, then negative 3i must also be a root. So I need x plus 3i rather. Okay, now we're going to FOIL this out. X times x is x squared. X times 3i is 3xi. Negative 3i times x is negative 3ix. So those two are going to cancel out. And then I'll have minus 3i times 3i, which would be 9i squared. Now remember, I squared is negative 1, so what this really is x squared minus 9 times negative 1, which would give us x squared plus 9. That's all we've got for today's lesson. We'll be back tomorrow.